Alright, so today we're going to look at the multiplication properties of exponents. What are some shortcuts that we can use in multiplying a couple powers together? So you can get away with not using any of these shortcuts, but you'll realize that once you do a lot of these, you start to come up with some shortcuts on your own. So we're just going to front load this and give you some shortcuts, and then I'm actually going to show you how they came about and how they were developed. So the first one is called product of powers property. Okay, so product of powers. It means you have a product, so two things being multiplied, and their powers. Remember, power is a base and an exponent together. So let's say you have a to the m power times a to the power of n. So the shortcut is going to be, all you got to do is keep the base and you add m plus n. Okay, now I'm all about proving this to you and showing you why and how we get this. So let me show you with numbers. Say a is actually a 4, and I have 4 to the second power. Let's make this an example of this. And then I have 4 to the third power. Okay, now I'm going to write this in expanded form so you see where the idea comes from. What this means is that you have 4 times 4, that's what 4 squared means, 4 to the second power, times 4 to the third. That means I have 4 multiplied itself 3 more times. 4 times 4 times 4. Okay, so this was 4 squared. Let me just group these. That was the first expression. That's the second one. But altogether, we really see that there are how many 4s? 1, 2, 3, 4, 5. So I could just say 4 to the fifth power. So what we're doing is we're going from this expression, jumping over the expanded form straight to this. So that way you can realize, well, if I know there's 2 of them here and there's 3 more here, then can I just say that there's 5 altogether? And that's what this rule is telling you. It's telling you that if you know that you have this many a's and then you got more a's, then why don't you just add them up, and that's how many a's raised to that power. Okay. The next one is called power of a power property. And what that means is you have a power raised to another power. So a power looks like this. So you have a to the m raised to another power. Okay. And the shortcut for that would be, it's going to be saving you some time if you just write a to the m times n. Okay. Now again, let me show you why that works. An example of this would look like this. Say we have 4 to the 6th power, and then again raised to the 3rd power. Okay, so what that means is I have, or I'm repeatedly multiplying 4 6 times. So I have 1, 2, 3, 4, 5, 6. Now, that's 4 to the 6th power. How many times is this happening? The power of 3 means to take this 3 times. So that's 1 time. Do it again. 1, 2, 3, 4, 5, 6. That's the second time. And then I'm going to do it one more. 4 to the 6th a third time. 1, 2, 3, 4, 5, 6. Barely fit it on there. And that's the third time. So if you notice, 4 to the 6th, doing 4 to the 6th 3 times leads me to how many 4s altogether? 6 plus 6 plus 6 gives me 4 to the 18th power. Okay. Now, you realize we didn't have to write it all out. I could have just said, what's 6 times 3? 18. So that's the idea. Okay, it's saving us all that time, and it's just a rule that we want to do because no one wants to spend time writing it all out. And the other one is power of a product property. All right, power of a product. Now what does that mean? Power of a product. So we have a product, right? Something times something else. And then we're raising it to a power. Say it's, I don't know, m. So what does that do? Well, it means that you're going to just have a m times and b multiplied m times. That's the shortcut. Okay, and it's very good for you to reference this because you are going to see problems, and if you see them match this format, then you can just use the rules. So keep this handy as you do your practice problems because it's going to be helpful. And let me show you how that one came about. Again, let's do another little example. An example would be, let's say 3 times 2, and we'll say it's to the 5th power. So what does that mean? It means I'm going to have 3 times 2, 5 times. 3 times 2, 3 times 2, that's 2 times. That's 3 times. That's 4 times. That's 5 times. So I have 3 times 2, 5 times, multiplied itself 5 times. Okay, so now what I can do is I can put all my 3's together first, and I have 1, 2, 3, 4, 5. So if 3 is multiplied, and a commutative property of multiplication means I can multiply these in any order as long as they get multiplied. It does not change my answer. So I want to take all my 3's multiplied first. Okay, and I'm just going to switch colors so you can see the... Now I'm going to take all my 2's. 1, 2, 3, 4, 5. So now I want to take all my 2's together and multiply all of those together. And I'm going to have 2 multiplied to itself 5 times. Right? It doesn't matter what order I do that in, but I'm organizing, taking up all my 3's first, then all my 2's. So you realize I didn't have to do all that. I really just had to say, oh, so A is going to show up m times, 3 is going to show up 5 times, or get multiplied 5 times, and B is going to get multiplied m times also. That would be 2 gets multiplied 5 times also. So the way I like to think of this is like it's not really a distributive property, but it's kind of like you are distributing it, right? The m is going to go on this guy, and the m is also going to go on that one. So they both get m to the raised to the m power. All right, so let's go ahead and practice some of these. If you have this, don't turn the page, or you might want to reference it later. All right, so let's look at example 1. And we're going to rewrite them with the same base, so we're going to just simplify. So whatever they give me, I have to make sure my answer looks simpler, shorter, more compact. So I have 2 to the 4th power times 2 to the 5th power. Now, if I were to write this in expanded form, it would be 2 times 2 times 2 times 2. That's 2 to the 4th. And then you're multiplying 5 more. Times 2 times 2 times 2 times 2 times 2. So if you expand this all out, you realize that you're writing 2 multiplied itself many times. And the shortcut would be to just write 2 to the power of 4 plus 5. Right? Because this many here plus this many here all together gives me 2 to the 9th power. So I'm multiplying 2 by itself 9 times. All right, and before I do example B, I want you to note something. That in mathematics, when you have x, it's actually the same as x to the 1st power. Now, we don't usually put a 1 because obviously if you just see there's an x there, you know there's just one of them. So it's kind of redundant to draw the 1 in the exponent. But sometimes when we're applying the rules, we might want to write that 1 down just so that we can identify it and use it like we do all the other numbers. So let's look at example B. Example B says -5 times -5 to the 6th power. Okay, now this does not have an exponent. Now why is this one not in parentheses? Well, because it doesn't have an exponent, there's nothing to be grouped. But if I could put a 1, I could. And this negative, even if it tags along to the 5, is still a -5. So the rule says I would keep the same base and I would just add the exponents. 1 plus 6. So my answer is going to be, keep the parentheses, I want this entire number, -5, the negative and the 5, to be raised to the 7th power. And that is your answer. Okay. And C, it's telling me I have x to the 3rd times x to the 7th. Now I have variables, but it doesn't matter, right? I have x times x times x, and then over here I have times x times x times x times x times x times x times x. So all together, you have a lot of x's, right? So it's going to be x to the 3 plus 7. That's the shortcut. 3 of them here, 7 of them here. Then I know that all together, I have 10 x's multiplied together. Now, the rules were to simplify. It did not tell me to calculate or evaluate, so I don't have to calculate what this is. I'm just writing the power in a simpler way. I'm writing this expression, or power, in a simpler way. And these two combined look simpler this way. All right, so example 2. And obviously we're going to be seeing some examples of all the other properties we mentioned earlier. It has 2 parts. 3 to the 4th to the 3rd. And w to the 5th raised to the 4th power. Now this is all about using the properties. Okay, I can do this in expanded form and show you guys how you get the answer. But the idea is for you to use the properties, and that's what this lesson's about. So, power to a power. That was this one. If you got something a number of times, and then you got that an additional number of times, then you're going to end up having 6 3 times, which is how we got 18. So in this case, the rule is the same thing. We're going to multiply. Okay? And so that means I'm going to have 3 to the 4th to the 12th. I'm sorry, 3 to the 4th to the 3rd. When you multiply, you get 12. Okay? And what I like to do, and I've done this for many years, it's just my little way of knowing what I'm doing and not confusing it with something else. I usually put like a little mark right here. And that reminds me to multiply. It looks like a little X. So that reminds me that if I can put that little X here, then it means 3 to the 4 times 3. Okay? Just a little side note to remind you when you're supposed to multiply. And that is simpler. So we're done. For this one, I have power to a power. And I could put my little times table mark there, which reminds me that the rule is to multiply. So I have w 5 times, another w 5 times, another w 5 times, w 5 times. So a total of 20 w's would have been listed. We don't have time to list them all, so we're just going to say w to the 5 times 4 will be w to the 20th power. Okay. All right, and one more example. Example 3. And example 3 says 2x to the 3rd power. And again, we're going to simplify. Write it in the simplest terms. 2x to the 3rd power, and then we got b that says 3xy to the second power. So, again, we got 2x 3 times. So you can visualize this as 2x times 2x times 2x. Now, if we did that, you would have seen the 2 multiplied 3 times. Or the rule was to take this 3, and it's going to become the exponent on both of those. I see 2 things in here. I see a 2 times an x, so both of those will get a third power. So it's going to become 2 to the third power. And then x is also going to be repeated in that expression 3 times, so it's going to be 3 of those. And then when we're doing this, we don't really need the dot, so it'll just be 2 to the third, x to the third. And we're going to go ahead, if you want, you can put 2 times 2 times 2, which is 8, x to the third. Okay, so that would be that would be 4 times 2 equals 8. All right, so that's the simplified version of that one. That's a 3. And B, how many factors do you see in this parenthesis? There's 3 of them in here. So each one of them is going to get a second power. So this 2 is going to go on the 3, on the x, and on the y. Okay? Every single little thing in the parentheses is going to show up twice, because it says to take all of this twice. So if I were to write this in expanded form, I'm going to end up seeing 3 multiplied by itself twice. If I look at the expanded form, we're going to see x multiplied twice, and the y will be multiplied twice. And we can go ahead and do this too. What's 3 times 3? 9, x squared, y squared. All right, and there you go.